Hey students, ever noticed how mayonnaise or your favorite salad dressing stays thick and creamy even though oil and water don't mix? That's the magic of emulsions. Let's take a deeper dive into what emulsions really are. Emulsions are colloidal dispersions where two immiscible liquids like oil and water come together. One acts as the dispersion medium and the other becomes the dispersed phase. Think of it like this. In a mayonnaise bottle, oil is the dispersed phase and water is the dispersion medium. Now, emulsions come in two types, oil in water, where oil droplets are dispersed in water, and water in oil, WO, where water droplets are dispersed in oil. You've probably seen both in action. Milk is a perfect example of an oil-in-water emulsion, where fat droplets are suspended in water. The second type? Well, if you've ever used cod liver oil, that's a water in oil emulsion. Cool, right? So, emulsions are everywhere around us and they make our world a bit more interesting. Now, let's talk about the oil-in-water emulsion. Imagine the fat in milk. That's all suspended in water. In this type, oil is the dispersed phase and water is the dispersion medium. Milk is one of the most common examples where tiny fat droplets are spread evenly in water thanks to an emulsifying agent. This makes the fat droplets so small that they stay suspended instead of separating. Just like how you can't see the tiny fat droplets in milk but know they're there. Oil-in-water emulsions are used in food, cosmetics, and medicines. So, next time you take a spoonful of milk, you're actually experiencing a beautiful emulsion in action. It's the chemistry that makes your morning coffee so creamy. Let's flip things around and take a look at water in oil emulsions. In this case, water droplets are dispersed in oil, making all the dispersion medium and water the dispersed phase. A great example of this is cod liver oil. While the oil is the dominant phase, it contains water droplets suspended within it. The most interesting part about this type of emulsion is how it's commonly used in cosmetics and ointments because it creates a thicker, more protective texture. Water in oil emulsions are fantastic when you need that extra layer of protection, like in cold creams that help protect your skin in winter. So, next time you use some cold cream, remember, it's all about chemistry keeping your skin hydrated and protected. Here's where it gets really fascinating. Ever wonder how two immiscible liquids like oil and water stay mixed together without separating? That's the job of emulsifiers. These little heroes are molecules that have two parts, one that's attracted to water and the other that's attracted to oil. Think of them like little bridges connecting the oil and water together. When soap is added to water and oil, its molecules arrange themselves so the hydrophilic, water-loving, heads stick to the water droplets and the hydrophobic, oil-loving, tails stick to the oil droplets. This reduces surface tension and keeps the oil and water from separating. So, next time you wash your hands with soap, you're witnessing emulsification happening right before your eyes. Soap is doing its magic, breaking down oils and dirt into tiny droplets that wash away easily. Okay, so how do you tell whether you have an oil-in-water or water-in-oil emulsion? Well, there are a few cool tests you can do. First up, the dye test. If you add a water-soluble dye to an emulsion and the color spreads through the liquid, it's likely an oil-in-water emulsion. On the other hand, if the dye stays concentrated in one place and doesn't spread out, it's a water-in-oil emulsion. Another way to tell is with conductivity. Oil doesn't conduct electricity, but if you have an oil-in-water emulsion, it might show some conductivity due to the water phase. So, these tests make it easy to tell which emulsion you're dealing with. Isn't it amazing that chemistry allows us to break things down so precisely? Now, you're probably wondering, What are emulsions good for? Well, they're everywhere. First off, emulsions are key in pharmaceuticals. Lotions, creams, and ointments are often emulsions that help deliver medication to your skin. They're easy to absorb and keep your skin smooth and hydrated. In the food industry, emulsions are used in things like mayonnaise, dressings, and ice cream, making them creamy and smooth. But emulsions aren't just limited to cosmetics and food. They're used in detergents, paints, and even in the oil industry, where they help in the separation and extraction of oil. So, emulsions are a big deal, and they play a huge role in making our everyday products better. Let's dive a little deeper with an advanced example. Remember the soap molecules we talked about earlier? Well, soap works as an emulsifier, but let's break down how it does its job. When soap is added to an oil-in-water emulsion, the soap molecules arrange themselves in a way that their hydrophilic heads are attracted to the water and the hydrophobic tails to the oil droplets. The soap molecules essentially wrap around the oil droplets and form a protective barrier, which keeps the droplets from combining back into a big glob of oil. This creates a stable emulsion. So, in essence, soap doesn't just clean, it also helps mix things that wouldn't normally blend together. It's like a superhero of chemistry. So, to sum it all up, emulsions are fascinating systems where two immiscible liquids, like oil and water, come together thanks to an emulsifier. Whether it's oil in water or water in oil, these emulsions are vital in food, medicine, cosmetics, and even in the industrial world. We've seen how emulsifiers like soap play a key role in stabilizing these systems and making sure that two liquids that don't mix stay mixed. So, next time you use a cream, eat some mayonnaise, or even clean with soap, remember the amazing chemistry happening behind the scenes. Chemistry truly is everywhere, from your kitchen to your skincare routine, keeping things running smoothly.